Welcome back, dear viewers. This is continuation of another video, and in this series we are trying to understand how we can build a AI model to classify different heart disease with the FusionNet dataset. And in the earliest videos we have seen how a signal could be represented into a time frequency representation. Now plotting one ECG signal is cool, but if we have thousands of them, and if you have to use it for deep learning model, then this will be a tedious task. And doing this manually will destroy your sanity. So today we are building a very fast MATLAB automation script. And with this one script, what we can do is we can take a raw hard data, convert it to time frequency scaleogram, resize them, and drops them into label folders for a neural network. Let's automate. And before I go ahead, I'll just like to show you, I did this previously. So if I go ahead and I take you to the location, I have a folder over here named data. And if you go to this folders, you can already see that some data is present. So what am I going to do is, I'm going to delete everything which is inside this particular folder. So this is as good as, I have this particular folder data, and inside this data I have nothing over here, right? And if required, I'll also try to, we can also try and delete this particular folder. Let's try to delete it. Let me first explain you the code, and then we'll try and run this. So what we do is we start defining by our file paths. This particular step is very important. So over here, the parent directory is the present working directory right now, and the data directory is set to be a folder with the name data. Now if you look at our helper function, we can find out there are few lines that check if this folder exists or not. And if not, then this folder will be automatically created, okay, before the real magic even begins. Next, what we do is we try to extract our signal data and categorical labels. Then we instantiate our secret weapon, and you already know name of this weapon, which is wavelet transform. So what we do is we create our custom wavelet transform over here. Fine. Next, you can find out over here we have a for loop. Now what exactly is happening inside this for loop? Inside this for loop, we calculate the absolute wavelet coefficients. So this is the absolute wavelet coefficients that we are capturing, right? Okay. But you will also find out that we are using a function which is rescale over here. And what this rescale function is trying to do is, it's trying to map the coefficient between the values 0 to 1 to 7. Also, we are using this function ind to RGB. Now, if you're not aware about what this function is, in MATLAB, what you can do is, you can go and you can search for this particular function. So over here, you can open this function, or you can click on help on this function, and it will try to provide you the documentation, and you can go ahead and we can view this documentation. I'm skipping it right now for this particular part. But what this function does, IND to RGB. And with this IND to RGB, we also have jet 120 over here. So what we are trying to do is, we are trying to directly represent our transform into a raw RGB image matrix. Because the deep learning model which we are going to train later on will require some features from this particular time frequency transforms or images. Right? Now it's time for us to look at our labels. So if you look over here, there are three labels in a data set. These are ARR, CHF, and NSR. So what we'll find out over here, that this particular label folders will be automatically created, and then later on each image or we can say each signal which is represented as time frequency signal will be resized first. Now why you want to resize it? You want to resize is because this is the final missing touch. Most of the convolutional neural network will demand that the input images are of a particular size. For example, 224 by 224 pixels. So here we are trying to resize our RGB matrix. Okay. And then what we'll find out, that we have been able to create, our data set with this particular script. So let's try and run the script. Scripts is working. You can observe now that the data folder is created. Next, what you'll find out, it will try to create the folder ARR. If you remember, see, it has tried to also update all the ECG signals belonging to ARR class by its time frequency representation. Let's wait for some time so that the scripts gets terminated, and when it's going to terminate, when all the ECG signals would be represented as time frequency representation. That's all from my side. If you really like this video, okay, I request you to please hit on the subscribe button. And in the next part, what we'll try to do is, we'll try to actually train our neural network, and then we'll observe the results. Thank you guys. Bye.